Welcome again to this dialogue webinar. And I would like to introduce to you this morning, and even in some other parts of the world, in behalf of the Independent Council for Road Safety International, I welcome and thank Dr. Matteo Rizzi, who is at the Swedish Transport Administration. Matteo has long experience on working with traffic safety related research and analysis. Matteo represents Swedish Transport Administration in the Safer Management Group, supporting safer work towards the overall aim to support the Swedish Vision Zero. Matteo came to Swedish in 2003 and as a exchange student with the Erasmus program. After finalizing his master's degree, he started to work in the STA on accident analysis, accident investigation, accident assessment, and safety assessment. He started his doctoral studies at Monash University as Accident Research Center in 2010, before started as a researcher at the Falklands Chambers in 2012. Mateo's doctoral thesis was about the importance of ABS braking on motorcycles. Finally, he started again as the Swedish Transport Administration in 2017, where he works as an analyst. Now is with us, and I give you the floor. Matteo, thank you very much again.
Thank you. Thank you for a kind presentation. Yes, so first of all, today I would like to acknowledge the support, the contribution of Outlive with this presentation. And today we're going to talk about the future of motorcycle safety. So this outline of my presentation. First, I will briefly explain the principles of Vision Zero. After that, we'll discuss briefly the injury risk for motorcyclists in different situations. That will look at an international comparison of crash statistics across 3 different countries of the world. Then we'll discuss a couple of future possibilities for us to increase safety for motorcyclists in the future, and then finally conclusions. And I'm sure we'll have a great discussion. So Vision Zero, let me just move some stuff around here on my desktop. So Vision Zero, what is it? It's basically an approach to address road injuries, and that means that we don't see roads injuries an inevitable consequence of mobility, and that we do take responsibility for those injuries when they do occur. We have 2 basic starting points. The first one is that humans have biomechanical limits, which means that our body can only tolerate a certain amount of blunt force before injury occurs. The second point is nobody's perfect. That is, we all make errors or mistakes sometimes, which is something that was already realized by this guy called Seneca 2000 years ago, when he claimed that it's human to make errors. With those 2 starting points in mind, the vision is that all crashes should be survivable. And in order to achieve that, we need to build a road transport system that can absorb human error by handling the input energy in a crash. So really, it's not about the crashes themselves, it's about the consequences of crashes. And to illustrate this a little bit more in detail, we can look at the chain of events leading to a crash. And that's nothing else than a timeline. But we can look at it as if unfolds backwards, so the other way around, so to speak. We can start from the crash, because that's our focus, that's where the injury can occur. And you move backwards, you get further and further in time and space from the actual crash. And closer to this phase called normal driving, where we can simply say where everything is under control. So basically in this timeline, there is a point of no return. Generally speaking, approximately 1 second before the crash. And that means that after that point, you need to accept the crash is going to happen. And we need and want to protect road users to avoid injuries. For instance, with seatbelts, airbags, helmets, things like that. When in the middle of the chain of events, you can imagine putting imaginary barriers to break the chain and go back to normal driving that is preventing the actual crash. For instance, barriers, anti-lock brakes, rumble strips, this kind of stuff. So I would like to illustrate a little bit to these concepts further by using two examples here, but discussing what is the difference between a bicycle and an airplane? And of course, I'm aware there are endless and countless differences between an airplane and a bicycle. One is supposed to be flying and the other is not supposed to be flying. But in this specific context, I think the most relevant difference is the energy that we need to handle when a crash occurs. So in terms of airplanes, we have a transfer mode where we can't allow crashes to occur because the input energy is simply too high to be handled. That means we need to put plenty of barriers here in the middle of the chain of events to make sure we never go all the way to the crash. Just a few examples: air traffic control, advanced warning and supporting systems in the airplane, also maintenance, technical checkups, and this kind of stuff. And of course, very high requirements on the pilots, on the users of the airplanes, when it comes to skills, medical conditions, their training, and so on. Speaking of bicycles instead, that's almost the other way around. We have a transport mode where we may neither want nor actually be able to have a lot of requirements on the users. However, what we can do is to handle the input energy in a crash. And in fact, it's not a matter of if we can do it, it's more of a matter of how we do it. So, for instance, we can prevent serious injuries with helmets. But of course, it's just as important to have to develop countermeasures in the middle of the chain of events to break the chain whenever possible, like bicycle-friendly infrastructures, road maintenance, and stuff. But still, again, the basic idea is that focusing on the middle of the chain of events when speaking about a bicycle is not enough, because bicycle crashes will simply always occur, and we need to protect bicyclists. So in other words, these were just two simple examples to really explain the basic idea behind Vision Zero. So in other words, there is a huge difference between talking about zero crashes and zero fatalities. There's a huge difference between those two things. So the goal is now not to totally eliminate the number of crashes. The goal of Vision Zero is really to make sure that speed is always aligned with the ability to protect road users when something happens. And again, please note, I'm not saying if something happens, if a crash occurs, I'm saying when a crash occurs. The challenge when it comes to motorcyclists is that, this is challenging. So if we go back to the bicycle versus airplane illustrations, one could ask, all right, what approach do we use for motorcyclists? Do we use the bicycle approach, where we can handle most of the input energy, or do we use the airplane approach, where we cannot handle the input energy, so we need basically to rely heavily on crash avoidance? Well, my very personal answer to that question is a bit of both, actually. I think in this very simple graph, motorcycles will be somewhere in between an airplane and a bicycle. And whether it would be more towards the one or the other, I think depends on the level of input energy we're talking about, what kind of speeds we're talking about, what kind of environments we're talking about. But again, speed is energy, and energy is the key factor when it comes to safety, I think. And speaking of speed, there's a quite recent study investigating the relationship between input speed and injury risk for motorcyclists. This study was conducted by Outlive, STA, represented by myself, ICoRSI and Pioneer. I will show you some highlights from this study, different levels of injury risk in different crash configurations and things. But before I do that, I would like to stress the importance and the need of such relationships. As I mentioned earlier, the basic idea provisions here is that road users should not be exposed to levels of crash severity, levels of energy that is not survivable. This means that we need to be able to quantify injury risks at a certain speed and crash opponents for each and every type of road users we have out there on our roads. In this particular case, we define crash severity as input speed or relative speed when another motor vehicle was involved, and we define injury as severe MS3+ and fatal injuries. And I also need to stress the fact that these relationships are based on real-life crash data, which means that they represent the level of crash protection offered by today's protective gear, road infrastructure, cars, and so on. So this gives us a snapshot of today's injury risks for motorcyclists. Not much to say here other than that we use the GIDAS, the German in-depth accidents database. And after some cleanup in the material, we had roughly 2,000 cases for analysis. All riders included in the study had helmets. And this is what the results look like. We generated 4 risk curves for depending on the crash opponents. Top left is represents a head-on crash against passenger car. And we have top right road barriers of any type. Unfortunately, we had to group road barriers of any type due to the lack of material. Bottom left road surface, and bottom right trees or posts, this kind of objects, narrow objects. And the kind of pink shadows you see above and below the curves are the representing 95% confidence limits, which unfortunately are quite huge due to the limited material. So just a few examples to understand a little bit more what these risk curves really mean. Let's look at a crash at 50 kph. Let's just imagine motorcycle driving and crashing at 50 kph against different collision partners. In the case of a head-on crash against a passenger car, also driving at 50 kph, we will have around the 50% risk of severe and fatal injuries. And basically the same magnitude of risk for severe and fatal injuries if you crash into a tree post or a road barrier. So the only the only situation in which at this speed the injury risk will be reasonably low will be when you basically don't crash with anything. It's just a road surface. And of course, the higher the speed, the higher the injury risks. This slide here show the risks at 78 kph, which happens to be the average traveling speed for motorcycles in Sweden. And this, I think, suggests that as of today, motorcyclists are exposed to injury risks if something happens. Injuries that they're huge. I mean, they're not acceptable. Also, when it comes to the roadside, similar results at 70 kph, which is, at least in Europe, a pretty common speed limit. There is some evidence suggesting that a road barrier given the same speed will imply a lower injury risk than impacting with a tree, but they are still very, very high injury risk nonetheless. And again, the only way to have a reasonable injury risk is not to collide with anything, basically. This one we can skip. So, so far we've been talking about motorcyclists in general, as they were a homogeneous group with very little variation within the group. Is it really that way? I mean, is the nature of motorcycling, the way motorcycles are used, pretty much the same around the globe? Well, of course, my answer to the question is a clear no. And we have another study from our colleagues at Autoliv that is under review for publication in AP that has looked at this issue, the differences across different countries. And I did that by comparing motorcycle crashes in 3 different countries. The countries were China, they use CIDAS, Germany, GIDAS, and India. They use the ICoRSI database. So I'm just going to give you a really brief overview of some of the results. What we see here is the distribution of road use type in the three database in the 3 countries. In China and India, motorcyclists accounted for approximately 25% of all injured on the roads, while in Germany it was less than 10%. Then it's also quite interesting, I think, to look at what kind of motorcycles were involved in the crash, not because of the motorcycles per se. I think it's more of because that gives us indication of what the motorcycles are used for. It's more of a proxy of usage, I think. In India and China, the majority of the motorcycles involved in the crash were smaller motorcycles or even mopeds, which suggests they were used for commuting and transport. While in Germany they had beer bikes, suggesting a larger portion of recreational or leisure riding. And that is also reflected by the number of people actually sitting on the bike at the time of the crash. In China and India, it was more common to have 1 passenger or even several passengers. see here, as opposed to Germany, where 93% of injured were the actually driver of the motorcycle. For distance, for difference was the rates of helmets usage. In Germany, the great majority did use the helmets, while sadly in China and India, it was basically the other way around. So, I mean, this, oh yes, another slide. It's also very interesting to look at the collision partner. And here things look a little bit more in line, a little more similar. The most common collision partner was a passenger car or a truck in all 3 countries. So again, just a rough overview. This work has been submitted and is under review by AAP. So, so far, we have been talking about the issues to address, could we say. What about the solutions? Well, the traditional approach to motorcycle safety is, I think, mostly based on 2 main pillars. The first pillar is either education and training, and as well as for enforcement. That is to avoid or limit errors, mistakes, misjudgments, to handle the motorcycle properly, to recognize the dangers out there, and these kind of things. That is, if we look at the chain of events leading to a crash again, that is means try and keeping the rider in the in this section of the chain of events, on the left section, so to speak. The second pillar is the use of protective gear, mostly helmets, but also in some regions of the world, it's not common to use protective clothing, normally equipped with energy-absorbing material. And that is, of course, on the very right of the chain of events leading to a crash. Both pillars have been shown to be very effective, but what can I argue that there is there's simply a gap here in between the far left and the far right ends of the chain of events. And that's where we need more systematic barriers to break the chain of events leading to a crash. Excuse me. Sorry, just looking at the chat, but yes, it was nothing relevant, I think, to this presentation right now. All right. So yes, again, we have this gap in the middle section of the chain of events. Something that is quite common to happen in that section of the chain of events is some kind of loss of control. And that is simply due to the fact that motorcycles are essentially unstable vehicles, and while in motions they're kept stable by the gyroscopic effect of the wheels in rotation, and also by the lateral grip of the tires. And if one of these 2 factors is compromised, for instance, by locking a wheel during hard braking, or losing the grip while cornering, a motorcycle will become unstable, and the most likely consequence is that you end up like one of these 2 guys. That is, there's not much you can do other than sliding on the road surface and relying on protective gear, if you have any. So, a system that is designed to address instability during braking is ABS brakes, anti-lock brakes. And this short film here just show an early demonstration of the benefits of ABS while braking on a slippery surface. I would also like to mention that motorcycle ABS has been around for more than 30 years now. It started in 1988 with the BMW K series, and during the years has been further developed not only in size and weight, as we see here, but also in the actual functionality, for instance, by integrating ABS with linked brakes, also called CBS. What about research and evaluations? Well, there is a lot of quite a lot of scientific evidence regarding the importance of ABS for safety. These are just a few examples. And there are also a few studies carried out in Sweden, were including my PhD thesis, all of them based on real-life crashes. I would like to show you some results real quick. Here we have analyzed police reports to evaluate and compare the effectiveness of ABS in reducing crashes in Sweden, Italy, and Spain. There is 3 countries with different motorcycling habits, different weather conditions, infrastructure, motorcycle fleets, and so on. What we see are the results for all motorcycle types regarding the reduction of all injury crashes, that is all crashes regarding of injury outcome, and also the severe and fatals separately. So the reduction of all injury crashes ranged from 24% in Italy, 29% in Spain, and 34% in Sweden. And looking at severe and fatals, the reductions were even higher at 34% in Spain and 42% in Sweden. Looking at scooters only, at least 200cc, 250cc, that's because they were the only ones available with ABS at that time, including in crash databases anyway. The reductions of injury crashes were similar to the overall results, ranging from 27% in Italy to 22% in Spain, while the reduction of severe and fatals based on Spanish material only was similar at 31%. And these results, I think, they are pretty much in line with other studies, other evaluations of ABS effectiveness, also from the US. Then we had another study carried out, well, based on in-depth database from Sweden and Norway. We analyzed the crash posture in fatal crashes, that is, whether the rider was sitting on the bike, the crash occurred upright, or the crash was a sliding one, that is, the rider was separated from the bike and was just sliding into whatever he or she crashed. What we found was that almost 90% of crashes with ABS were upright, compared to 65% without ABS. However, it's also pretty clear that if you don't brake, you should not see any benefits from ABS, right? I mean, you should not get any benefits from a braking system if you don't apply the brakes, which actually is what we did see here in the study. As you can see, the ABS and non-ABS bikes had exactly the same distribution of upright and sliding crashes when the rider did not apply the brakes before collision. Yes. While when the rider did brake before collision, we found that all ABS crashes were upright. compared to approximately a 50-50 scenario without ABS that is normally reported in other studies as well. So in other words, even though this is based on a quite limited material, and I think that needs to be mentioned, of course, our study suggested that the distribution between sliding and upright crashes changes a lot due to ABS. So what are the implications of these results, really? Well, I think this suggests, I mean, the main find is that improved stability with ABS kind of creates new scenarios for motorcycle safety. As I said, first of all, ABS can prevent crashes, but secondly, but in a way even more importantly, I think, crashes that do occur are also affected and become in a way more predictable. They're more likely to be upright. And I think that gives us new possibility and creates new conditions for other countermeasures to be more effective. Because that means that we can have a greater focus on upright crashes. And that also means that the design of a motorcycle will become more important to mitigate injury in a crash, because the rider will be more often be sitting on the bike during the crash. And this was basically the the conclusion of my PhD thesis. In very simple words, that means that ABS, in a way, is the very first step towards safer motorcycling. And gladly, there has been a few legislations across the globe to make ABS mandatory. And the EU was, I think, the first one, then followed by Japan, India, Brazil, and Taiwan. There may be others. It is very possible this slide is not totally updated. Australia as well, I think. I'm happy to, if somebody has more info on that. But either ways, more needs to be done about implementing ABS all around the globe, either with legislation or by increasing the availability of ABS on all markets, even on a voluntary basis. So more to be done in this area. And again, by making sure the rider is more often on the bike, we can do more things. We can autonomous emergency braking is one of them. As we saw in the outlive comparison between Germany, India, and China, passenger cars were one of the more common, or actually
Matteo,
the most. Yes.
If you allowed me, before we go to this following session, there are some questions from the audience about ABS braking. And actually, Paola Flores from Latin America, she says that some people in Latin America believe that ABS brakes are very dangerous in motorcycles. Frequently, they are installed only in the front wheel, and she will ask and she would like to know if it's important to install this in both wheels, or only in the back wheel or in the front wheel.
Well, I mean, I think it may depend on what kind of road surface you drive, and there are people out there I know that suggest that it might be preferable to be able to lock the back wheel when you drive on gravel or drive off-roads. I think under normal driving conditions on a paved road, I don't think there is any reason not to have ABS on both wheels. Maybe the only reason is that, sure, I mean, I guess it's cheaper to have ABS on the wheel, and maybe you can implement it faster. In that case, if you only have one wheel, I will recommend strongly the front wheel. But from a safety point of view, I think it's very important to have ABS on both.
In both. Also,
yes.
Jorge Rubino asked, actually it was before, but I think it's take relevance to this point of your conference, that he says that based on the European experience, in the case of motorcycles, what do you think is better, training in braking techniques or using advanced systems like ABS?
Well, I mean, I think it's going to be very difficult to establish a training program and have it spread out in such a way so that you will reduce crashes in the same amounts, in the same crash reduction rate as ABS, to be honest. So my personal answer to the question is that I would, if I get the question correctly, I will definitely recommend going for ABS. Then I think it's always, one could discuss whether it's important to support consumers understanding the importance of the ABS and also the limitations of ABS, and also to understand the risks associated with wheel locking while driving a motorcycle. Have I answered the question, you think?
Yeah, so also Hilda Maria Gomez from Colombia, she's asking how important are the ABS brakes on the PTW, the power two-wheeler, on less than 50 centimeters cubic motorcycles?
I mean, that's a good question. If we look at this very slide here, seems like the general trend when it comes to legislation is to exclude the mopeds, right? I mean, the smaller bikes with engine displacement less than 50 cc. Why that is, I don't know. Why the legislation came up with that, I don't know. On the other hand, there are basically no real-life evaluations regarding ABS and mopeds. That's simply because mopeds don't have ABS. So I mean, it kind of gets in a catch-22, I guess. But I mean, I think definitely even a moped would benefit from ABS. And I'm hoping to see, at least on some markets, some mopeds to be equipped with ABS. So to answer shortly, yes, I think it will be good, but there is not lots of evidence suggesting that at this stage.
Yeah, this leads us to so many issues with this approach from the safety on the vehicles or infrastructure and other to let the people just make the right election or decision. And also someone, Giovanni Aldana, ask what is the cost to install or to put ABS in one motorcycle in a line production, I mean factory?
I mean, the cost these days, the costs are not very much. I mean, I read some figures some years ago, maybe it was 50 euros.
Okay.
I mean, I'm talking about the cost, not the price.
No,
so
it's the cost. Yeah.
Yes, the cost some couple of years ago was 50 euros. I think these days it's less than that.
And also that brings us to another thing that you were talking just a little bit before about the legislation and the standards from the country. I know here in Colombia, as long as I know, they are now working on safer standards, and they have been requested ABS for motorcycle, because here is still not mandatory. But
Right.
Jake Oliver just pointed out that ABS is not required in Australian standard. So that
Right.
just make me worry, because Australia, as long as I know, and you were in Monash and I was in Melbourne, they are very leading all the injury prevention and safe promotion around the country. So that is, I mean, I know there are some very long gap between public health and the people who are working in injury prevention and the legislators, but we have to just reduce that gap in pro of the safer for the people.
Yes. Yeah, I definitely agree. I mean, there's always another option compared to legislation. Of course, it's always possible to implement safety technology through on a voluntary basis. And maybe that's what's, I think, that's definitely what happened in Sweden when it comes to stability control, and also ABS, to be honest, for motorcycles. I mean, pretty much all of the new bikes in Sweden had ABS before the legislation, the EU legislation came. And and sometimes that process can be a lot faster than the legislation, because just as you mentioned, it takes a lot of time to make all politicians agree with each other, and it takes years, and then and so things happen a bit slowly. So the voluntary implementation can be faster, but it also needs a lot of commitment from the industry to make that happen. If the industry in a particular region of the world is not committed, then legislation is probably the only way to go. And although there are other mechanisms to make / force industry to commit to safety, for instance, the consumer programs, which we will be talking about later on.
Yes, and there is also some a question about now over the 50 cc, but 125 cc. So it says, based on the existing evidence, what we can say about the effectiveness of ABS on motorcycles or engines capacity under 125 cc. Do we need more evidence, or does the existing evidence strongly suggest benefits for low capacity?
Yeah, I definitely think so. I definitely think that I mean, there is sufficient evidence to suggest that ABS should be effective for low capacity bikes as well. I mean, at the end of the day, I think it's all about physics and vehicle dynamics, and wheel lock-in will have the same consequence. Given a certain speed, wheel lock-in will have the same consequences regarding how big engine you have, right? So, I mean, I will feel comfortable in claiming that ABS should be implemented on all PTWs, basically regardless of engine size. But what tried to say before was that I can understand that for some people it could be sometimes an issue when you don't have figures showing the effectiveness of ABS for just for those smaller volumes. So, but
yeah, let's put this discussion at the end, because there are so many things that the evidence make, and also the legislation go through, and even the industrial production of this device are also debating for no much cost. So it's something like
yes,
how important is the safer of the people. And actually, Dinesh Mohan just comment, if one of the poorest countries in the world, India, can mandate ABS for motorcycles above 125 cc, and the manufacturers have complied, so the cost can be major issue. So it's no issue. So how come they are no such a, I mean, it's 50 euros is not that much when you are buying this device, and the
no,
one
no,
life is a lot of cost.
yes,
So
yes, and I'm
we
yep.
will keep that discussion to the end, and I
Sure.
let you go
All right.
ahead. And I
Sure.
think it's a big issue, because sometimes we have been talking and talking, but what happened is nothing. I mean, this was also in Stockholm in the February meeting,
Sure.
but things go on and nothing happened. But let's do that at the end of I mean,
Yes.
in the middle, and let you go ahead. Thank
Thank you.
you, Matteo.
Just a final, no, thank
Okay.
you. Just a final note about the 50 euro figure. I mean, just take that with caution, as it's that was what I read a couple of years ago before the old legislations and things. So I'm quite sure now it's not less than that. How much less than that, I don't know, but I will say it's not more than 50 euros. It's probably maybe half of it. I don't know, but yeah. So, but I'm happy to find more recent cost figures for ABS later on.
Thank you.
All right. Let's see what, yes. So thank you for all the good questions. By the way, it's great to have a so a live audience. We're talking about ABS and kind of the what kind of new possibilities, new opportunities ABS gives us when it comes to motorcycle safety. And my point was by making sure the rider is sitting on the bike during the crash, before the crash, all the way, basically. At a greater extent, we can do more. And one of the things we can do is implementing autonomous emergency braking, AEB. As we saw in the outlet comparison between Germany, India, and China, passenger cars were the most common collision partner in motorcycle crashes, which of course implies that the car industry also has a share of the responsibility to address injuries among motorcyclists. And there is something that has been recognized in the Euro NCAP 2025 roadmap, where it is clearly stated that AEB technologies that detect motorcyclists should be tested and will be tested. And also quite interesting, there has been a lot of work going on at the University of Florence in Italy to develop autonomous emergency braking for motorcyclists. And that technology, I think we will be seeing this technology within a couple of years on a few high-end motorcycles. And what could be the benefits of such technologies? What could be the benefit of autonomously braking before collision. Let's look at an example again with our injury risk curves. So let's assume just for a second we have a head-on crash at 70 kph. On the x-axis we have the relative speed, as you see. That means we assume the car and the motorcycle travel at 70 kph. Both do that, and that will give us a relative speed of under 40 kph with a injury for severe and fatal injuries around 70-75%, which is ridiculously high, which means basically that 3 people out of 4 will die or get severe injuries. What if the car is fitted with AB? What if that AB technology could brake autonomously, reduce impulse speed by 15 kph before collision? Well, I mean, you will just move backwards in the curve. You will not longer have a relative speed of 130 kph. You will have a 125 relative speed. And the same idea will apply if also the motorcycle has AB. And some figures I read it could be up to 8 kph before collision, or actually a reduction of impulse speed by 8 kph. And this is just an example to illustrate the basic idea behind AB. So again, take this 15 and 8 kph with caution, but I mean, they seem reasonable at this stage. And then what if the motorcycle offers a higher degree of protection during the crash? You will still have the same relative speed. You will still have the same relative speed as you had before, but you will simply move downwards, so to say, in the graph. You will have a more flat injury risk curve. And let me illustrate this with some examples from our Autoliv colleagues. This illustration shows an airbag fitting on the motorcycle when impacting the side of the car, which is a pretty common crash scenario. The grayish one is the one with the airbag, as opposed to the reddish one without the airbag. And that is, I think, a pretty similar finding compared to the airbag solution proposed by Honda. These have been on the market for 14 years now. This, the airbag would help prevent the rider from impacting the roof of the car, which is a very, very stiff section of the car. Here we have another example of a scooter impacting at 50 kph into the side of the car. It is moving at 20 kph. The rider wearing helmets. According to the results shared by Autoliv, the rider will sustain substantial reduction in several injury risk criteria, both for the head, the brain, and the ribs. And I just think this looks very, very promising. However, I also like to mention that I have no detailed knowledge whatsoever of the solutions presented here in the Autoliv materials. So please feel free to contact Associate Professor Niels Lubbe at Autoliv for more details. Really, the point with me showing this is that I think that more can be done to protect riders. I think, in fact, that more should be done to protect riders. And just think this, I just find this example personally very interesting, considering it comes from a world-leading safety system supplier that in the past has not worked much with motorcycles. So I think it looks very exciting. And as I mentioned earlier, really briefly, a way to encourage the development and implementation of such technologies that is not through legislation could be a motorcycle consumer program similar to the NCAPS program developed for passenger cars all around the globe, well, in some regions, to be honest, of the world. My very personal suggestion would be that a rating system could be developed where all technologies improving stability could be rewarded. Although, of course, here we need scientific evidence to determine which technologies should be rewarded, should be included. One, I guess at this stage, will definitely be ABS, and then maybe other technologies could be evaluated and suggested for rating as well. Crashworthiness could definitely be tested. There is a ISO standard 13232, which at this stage seems to be a reasonable starting point to evaluate motorcycle crashworthiness. And well, finally, we could have a third score for anything that assists riders, for any kind of rider assistance score, such as ISA, the intelligent speed assistance, PSU speed, or autonomous emergency braking, improves visibility, and all these kind of things. But again, this is just my very personal suggestion. But the reason why I'm suggesting this is that we do know when it comes to car safety that all the NCAP programs around the globe have been extremely successful in promoting and encouraging safer products without legislation. So I think it's worth putting this on the table for discussion anyway. And finally, of course, let's not forget personal protective equipment, helmets, of course, and always, and also quite interesting inflatable jackets. There are a couple of pretty high-end products at this stage out there. They seem to be very promising. We have an example here. So basically, it's an airbag jacket. Some solutions are have the hardware and the software into the installed in the jacket. Some other versions have it installed on the bike, and they talk to each other via Bluetooth, I think. As usual, there are always pros and cons with any given solution or technology. One may argue that fitting the airbag on the bike will make sure it is always there, ready to do this job, and would possibly decrease the risk of misusage due to comfort issue, to heat, and these kind of things. On the other hand, one can also argue that inflatable jackets might be cheaper, might be easier and quicker to implement, and further advantages that it will be possible to move that between different bikes. I mean, we have one jacket for user, so to speak. I mean, either way, I'm not here to suggest a specific solution or technology. I'm just arguing once more that more can and should be done to increase rider protection. So I think it's time for me to wrap this up. So we start the presentation here by mentioning Vision Zero. The key message with that is that the road transport system needs to be able to absorb human error. We need to take into account the failing humans that will always make some errors sometimes. And therefore we need to be able to handle impact energy. And energy is just and speed really is energy, and that is the key factor for safety on the roads. That is quite challenging for motorcyclists indeed, and we're also seeing that today motorcyclists are exposed to high injury risks even at relatively low speed impact speeds. Another issue we need to keep in mind is that, of course, the way motorcycles are used and the nature of motorcycling is very different across the globe, and it's definitely something we need to keep in mind when designing new solutions. As we saw in China and India, lots of commuting transport as opposed to Germany and many European countries where it's motorcycling is totally different nature, is more about leisure and recreation. So very important thing to keep that in mind. Education, enforcement, protect the gear. Yes, they are very good, but we need to be more. As I showed, I think the first step towards safer motorcycling is ABS, because it can prevent crashes, and secondly, crashes that do occur are also, they become in a way more predictable as they are more likely to be upright, and that gives us new possibilities. That means that we can have a greater focus on upright crashes. And that in turn means that the design of the motorcycle becomes more important. It means that we can increase rider protection, for instance, with airbags. And a way to encourage this could be similarly to passenger cars, to develop consumer testing, like the new motorcycle assessment program. And I would also like to mention that of course the car industry also has an important role and responsibility to address re-injuries among motorcyclists. With that said, I would like to thank you for your attention and good questions. I'm looking forward a good discussion now. I would also like to thank our colleagues and friends and Autoliv for their contributions to this presentation. And on a very final note, off the record, I happen to be a passionate motorcyclist myself. I mean, you can't tell, but it's me in the picture, but you just need to trust me on this one. But yes, I guess that's why, I guess that explains why I'm so interested in this kind of research questions. So thank you.
No, thank you very much, Matteo. It was very good presentation. I think you addressed so many things that are going on, because mainly in our countries, as you show at the beginning of your slide presentation, there are so many issues with motorcycles due to the lack of public transportation, and also the cost of the vehicle is low compared with a car. So that's why there are more motorcycles in our streets at the city. So I will start with some questions from the audience. And one is from Pradeep Puthan. I hope I say very well the name. Is regarding motorcycle design. Does a three-wheel motorcycle provide enhanced safety with respect to crash worthiness and stability?
Well, first of all, let me say hi to Pradeep. I know him very well. It's one of the guys helping me out with the presentation, so thank you and hi.
Oh.
Let me back it up. So yes, for those of you who are not familiar with this, we're talking about this kind of design that is started around 2006 with the Piaggio MP3, and it's now become more popular. More OEMs are selling products with this double front wheel design. At this stage, there are, to my knowledge anyway, there are no real life evaluations regarding the benefits of such design. My personal hypothesis is that they probably do increase stability, but that's all my very personal hypothesis. And that's what I tried to say, I guess, with when I mentioned that, of course, before a future consumer testing program for motorcycles test and give points for such a solution, we need strong evidence suggesting that such solutions are effective, of course. So that was a very good question.
Yeah. And so also we have a question from Ronaldo Ferreira. He's saying to all of us that good evening, but what do you think about motorcyclists passing between cars on adjacent lanes in urban traffic? So the AED become it possible now?
I'm not sure I got the question. Is it in the chat? Can I read it myself?
Yes, it's in the questions and answers. Is after
see.
Is after Pradip. Two after Pradip. So I guess it's about the
sorry, struggling with, I'm not very familiar with Zoom, so just.
Okay, is
yes.
Near the participants?
Yes.
There is question and.
Is it an open? I don't.
It's
find
in
it.
open. There are 12 questions in open. So what do you think about motorcycles passing between cars on adjacent lanes in urban traffic?
Good question. I mean, that's a tricky one. That's a tricky one. I think. I mean, it's all about the relative speed, I think. I think if the cars are standing completely still and the motorcycle passes by at a reasonably low speed, that's fine.
But sometimes it's not as low. I see.
No, but that's what I mean. That's what I mean. I think it all comes down to what kind of relative speed you have between the car and the motorcycle. Well, let me explain this a little bit more. Of course, I'm not claiming that if the cars are moving at 100 kph and the motorcycle passes by 110, that is safe. But assuming that in this example, we're talking about a very a traffic jam where the cars are moving very, very slowly. If the bike moves slightly faster than the cars, I don't think that I don't see that as a big, probably the biggest safety issue we have with motorcycles, personally.
Okay, and Hilda Gomez also asked, do you know the Colombian airbags for motorcyclists?
No, I don't. Great. Please send more.
As long as I know, and Hilda might also know, there are no that issue yet in our motorcycles. They are debating for ABS, but no. I know for a long in the literature. For some time there are this issue going on, but up to now I don't see anything here about the airbags.
I see. No, sorry, I misunderstood the question. No, these examples are showed here. These are examples from How to Live. There is no, to my knowledge, there is no actual products. The only motorcycle that is sold with an airbag is on the Goldwing, and it's a very special bike. It's very huge, has a radial refrigerator, these kind of things. So and that's it. That's the only bike on the market at this stage that has an airbag. All our solutions are tests, experiments, and these kind of things. So And that's my point, really. There's been a motorcycle on the market, even though this is very particular bike. That bike has been on the market for 14 years, and I think that suggests that it should definitely be possible to do more, because obviously it is possible to have an airbag on the bike.
And the question again in our countries is how much for producers or is around the cost for these airbags?
I don't have any cost figure about airbags. However, I mean, this is the classic challenge with implemented new technologies. I mean, the price per unit or cost per unit is huge in the beginning, and then it cuts in half just a couple of years, and even half once more, and so on and so on. I mean, it's always like that.
So like new technology.
Yeah, but I mean, I'm not saying it's right, but I mean that's the way it has been, but also means that if you just wait a couple of years, the cost for certain technology is reduced to maybe 30% of the initial cost, which gives, of course, new possibility to other markets to also implement. So. And again, I think if we don't go for legislation, I think the only way to encourage and promote the implementation of more expensive but also safer products is to use this kind of consumer testing program, and also to raise the awareness among consumers. To basically to create a mechanism where safety really sells. When you make money with safety and you also make a good product.
Yeah, that brings me back to February, actually, in one of the different panels that I was participating, and that was with the representative of all the manufacturers for motorcycles, and they are believing, and I was kind of shocked, that everything have to be put, and they are investing on education. And as you know, education doesn't have much impact in all of this. And I think we should go ahead, kind of pressure, I don't know how, manufacturers to invest in those safety issues like ABS, like the airbags, like all of these things, to protect the users. I mean, the problem is huge in some countries, as you show, but they are not still aware, or maybe it's not politically correct or costly correct to have those things from the beginning. I mean, from manufacture.
Yeah, I definitely agree that's an issue. Well, I mean, I think this is also something very relevant to the Stockholm Declaration. That is how a big company, a world-leading company, what kind of responsibility do they take for the products they sell, they distribute, and of course, the entire value chain on these kind of things. But and there is something that is definitely relevant to the motorcycle market, I think, especially when it comes to actual products that are being sold. So yes, I mean, I do agree with you. I mean, it would be. I would definitely like to see more on a global market anyway, more responsibility taken from some motorcycle manufacturers. But yes, let's give them some time.
But how much time we have already through the decade of safety, road safety, and now in a second one, and we'll see about the same things going on. But anyway, is part we have to still be advocated for that. We have some thank you from Jorge Rubino to you, and he liked very much your talk, and also a question from Victor Valencia. What do you consider are the relevant characteristics of a good helmet?
Yeah, good question. I'm not sure I can give a good answer. Helmet design is not really my area of expertise, to be honest.
But at least they have to wear it.
At least they have to wear it.
The one with the standards. I think this is absolutely
definitely.
The recommendation is everybody who is riding a motorbike have to be wearing the helmet. I mean, it's no way that the people don't wear the helmet. Here in Colombia, sometimes they were selling the motorcycle with the helmet. Now they are not anymore. But I think this is another issue. Not only put the legislation, but also provide the people who have some cost problems. I mean, in our middle and low income countries, sometimes the people don't have even money, and they don't have the culture. I mean, it's more culturally to protect themselves and just to solve a problem of mobility.
Yeah, I agree. Of course, I definitely see the helmets as a sorry, I definitely see the helmet as a fundamental part of Vision Zero and motorcycle safety. I mean, without the helmets, I guess I can try to illustrate what I'm trying to say. As far as I am concerned, if we take away the helmets from a motorcyclist, we take away the little crash protection you have. And then that implies that you will have to move towards more of like the airplane safety approach, which with very hard controls and very, very much training of the rider and these kind of things. And I'm not sure you want to go that way. So also because I mean that's not feasible really. So yeah, I mean helmets. I think helmets are really fundamental for motorcycle safety.
Yeah, there are also some other questions because we are kind of at the end of the session. So Al can also ask if motorcycle a highway vehicle.
Highway vehicle, I guess, is we mean as high-speed vehicle. Yeah, I mean, it is, but today, as a matter of fact. But again, the level of protection offered by the infrastructure and the motorcycle and the gear you have on yourself is definitely not in line with the crash severity if something happens on a highway. I mean, we are quite unprotected as a motorcycle in highway speeds. So, and that's really also the challenge we have, I think, in the Nordic countries. As I told you, the average traveling speed for motorcycles in Sweden is 78 kph, and that's not because they drive like crazy. It's just because motorcyclists don't enjoy driving for recreation in traffic jams. They drive outside the countryside, and outside the countryside, you have higher speed areas. And that's why we have such a high traveling speed for motorcyclists. And I mean, that's a tough challenge. It's a tough challenge to protect today anyway, to protect the motorcyclist traveling the same speed as a car.
Yeah. So that leads me to one question I have always in mind, that again, with manufacturers, is should they put some limit of a speed, at least for cities. I mean, according with the evidence and your presentation, in urban areas should not be above 50 kilometers per hour. So it should be interesting that the manufacturers put some kind of control for exceed that speed limit, and also according with legislation on urban areas. So we'll decrease at least fatalities
Yes.
as we have. So, but
Yes, I
still
agree.
we have to work a lot with manufacturers.
Yeah, I mean, there are also a couple of solutions. Now we're talking about real advanced stuff like the geofencing. I mean, it's like a digital fencing. That is, when you enter a certain area in town, all vehicles are connected to the internet, and you basically cannot drive faster than the speed decided by the municipality. Of course, this. I mean, again, my guess it will take a while to get such technology implemented. But I mean, there are pretty cool ideas out there to really make sure that in the urban environment, so we have a lot of pedestrians and bicyclists and very vulnerable road users. It's a very nice way to make sure that all vehicles traveling around in those areas do follow a safe speed.
Yeah. Thank you. I continue with the questions. Giovanni Aldana asked if you have any idea what is the percentage of participation of the frontal impacts or crashes in any incident of motorcycles?
Read the question.
The front crashes in motorcycles. Just, I guess, for the airbags. I mean, I guess his question is about that.
I will have a very good answer in the how to live material, which unfortunately I haven't available on the screen right now. But I'm happy to get back to you. I think the frontal impact for a motorcycle, it was one of the most common ones. Then it's a question of whether the crash opponent is moving sideways or in the opposite direction. But as far as understood, the colleagues from How to Live draw the conclusion that the crash configurations tested in ISO 13232 are still quite relevant, and frontal impacts are definitely included in the ISO standard. So I think yes, they're definitely common.
Okay. Silvia Menduiña said, if according to your analysis, the ABS system improves security and the cost is relatively low regarding the cost of the motorcycle, why the manufacturers don't include it as a base design? What is your opinion, or what did you find in your research regarding this issue? Thank you for sharing your work. It was very interesting and educational.
Thank you. Yeah, I mean, this is again the same very good question we have been asking ourselves. I think throughout a big portion of this session. I mean, I think things are happening. I mean, I like to see it positively after all. I think things are happening. ABS has been implemented more and more, but I would definitely like to see things happening faster than they do. But I think, again, with a mixture of legislation and voluntary implementation, I think we will get further and further. But yeah, I mean, that's a very common challenge with all vehicle technologies. I think it takes time, and then it's if it's not mandatory, it's up to the manufacturer itself. And if you don't have this kind of mechanism where safety really sells, then it's basically up to them. And I definitely think that to initiate this mechanism where safety sells, we need this kind of consumer testing programs.
Okay. Also, there are some questions from. I think this I will leave it because I don't. So it's from Jorge Rubino. They said the industry sells ABS as an important quality in countries where it is mandatory, but says it is not necessary in our countries. That is a comment.
Well, that's sad to hear.
No, I know it's very sad, but this is true.
Yeah, definitely. I'm not questioning whether it is. I'm just say
it's a cruel reality.
Yeah, definitely.
And from Mexico, Sandra Treviño. She says, hello from Mexico. I agree that education is not the only strategy, but it is important to include it as a part of safety culture while traveling in roadways as pedestrians, as cyclists and motorcyclists, and of course of drivers and passengers of cars.
Yeah, I mean, definitely, it's definitely agreeable. And I mean, I think I would like just to stress on this issue that, of course, I'm an engineer, and I might sometimes sound like machines will solve all our problems, but I mean that's not really what I mean. You know, of course, education and enforcement, we will always need some kind of education and enforcement. That's really the basis of road safety. But we won't get that far with only those two pillars. We just simply need more if we really want to address road injuries. But there is no technology at this stage in a way that is so good that we can even claim we will never need any education or enforcement or these kind of things. So I mean, they're not mutually exclusive in a way. We need both. That's what I'm trying to say.
Yes, and also she said that manufacturers should sell safe products and governments must be strong on that issue. So we should wrapping up the session because we have just 1 minute left. Right. And I would like to thank you again for your wonderful presentation. I think there was very good questions from the audience. And I think it's a challenge for governments to think about as the people who lives and be in risk in the countries, and how to protect us, just dealing with the producers and manufacturers to bring a good product, just to decrease the cost of health and also the cost of society with the different lasting problems from this type of injuries. So Matteo, thank you very much. And thanks for all the audience and the interaction, the people who join us in this second day of the dialogues. And we see each other next Tuesday for a third day. And I wish you all good evening, Matteo, and all the persons who are in the part of your work. And also from us, buenos dias, and we'll see each other on Tuesday. Thank you very much.
Yeah, bye.
Bye.